lesson 12. Oh, let's switch on the light. Okay, so you see me better. Hello. Okay, I don't know why I show my face. Many people do, but it's totally useless. Okay, this lesson is on hash functions. I take for granted that you already know the beginning, so how to hash using the hash function of Python. So Python has inside a function which is called hash. It works only with strings, okay, and returns a number. I remind you that this number is calculated in a deterministic way, so it's not random. If you repeat it, you will get always the same number. Oops. Today I get if you repeat it on the same computer, you get always the same number. Interesting that the Mac gives me a number which is different from Windows. So if you repeat it on the same operating system, it gives you the same number. See, I repeat it over and over. Okay, so but if you just change any letter, for example, I remove the final I, the number changes completely. Okay. However, this function here gives a number. It's somehow limited for the use we want to make. We want to make to get a more complex structure because we want this number here to be somehow difficult to guess or to be very rare. Because it's a limited number, well, in this case it's not very limited, but on my Windows, as you have seen before, it was, say, something as 8 digits. It's easy to get the same, it's easy. There is the possibility to get one probability out of some billions to get the same number with different strings. Okay, we want to get usually different numbers, so we will use SHA-256, which is the basic thing which is used in modern computer application. It's a hash function, also SHA, so it's called hash function, even though it's not called hash. In Python doesn't exist by default. You have to write this thing here to import it from a library. So from hashlib import SHA-256, and then you have SHA available. Okay. So, and if you make SHA Satoshi, you get an object. In order to get the practical value, you have to add .hexdigest. Okay, in Python 3, it's slightly different. You have to specify the encoding here, but okay. Oh, now at the SHA is the same. Okay, luckily. So the hash depends on the computer you're using. The SHA doesn't. Okay, the SHA function gives you this thing here. For the one which are curious about technicalities, it's written in a hexadecimal format. Okay, it's basically a binary number, but written in a more human-readable way. Okay, so I imagine you have done this exercise already. Okay, this is the value you should get if you do it on Windows. Okay. Let's try to do it on the Mac. Just the exercise was part of the package 9, I think. Let me see. Yes. So let me see. Where is the import page here? Okay. Ctrl+C. I do the exercise so to check what is the value on the Mac. Page address equal Ctrl+C, Ctrl+V. Then I have to hash page.content print maybe. That's it. Okay, and the SHA. SHA, yes, I have .hexdigest. What's the problem? I have to import it from the library. Okay, that's it. So the SHA is always the same. This one on the Mac, we have seen that changes very well. Okay, so now if you on your Mac doesn't work, you know why. Okay, very strange because I tried it on the Mac also. Okay. However, this is the first usage we have already seen in the 9 exercise is using as a fingerprint for large data. So whenever you have large data, you're not interested in store this large data, so you don't want to waste your precious memory space to store this large data, such as in our web crawler where we don't want to store web pages. You can take the hash as a fingerprint of them. The hash is pretty short, so you can see here it's a string and not too long, much shorter than an entire web page, and you can have a fingerprint to check, for example, as we did before, whether you have already considered that item or not, okay, or to have a sort of index of the item. In fact, in Python, object dict, the dictionary that we have seen, uses this hash function. You don't see the fact that you don't see it using because it's transparent, so you don't see, but it uses exactly hash function as a fingerprint to be very efficient when storing your data. Okay, so this is the first usage. The second usage is to keep password secrets. Have you ever wondered, do you know what is a debit card? Well, I don't show you mine because then you will try to hack it. So a debit card, an ATM card, is something which I hope you have in your wallet, in your physical wallet, I mean. Okay, your debit card has a PIN, personal identification number, which is a secret code necessary to withdraw money or to use it. Have you ever asked yourself whether your bank knows your PIN? It must know it, because otherwise whenever you digit it, it can't check whether it's correct or not. Okay. Same thing for your web, for example, the password of a website. Have you ever asked yourself whether the website knows your password? It must know it, because otherwise how can it check whether the password is correct or not? However, probably you have noticed that some websites, whenever you click on I forgot my password, gives you immediately your password. Those are the websites which are not serious, and I include some website developed by me in which I store the password. Okay, serious websites don't store your password. So once you type the password, they don't store it, they forget it immediately. They have another strange technique to check whether your password is correct or not. And this is the reason why whenever you click on I forgot my password, they are not able to tell it to you again, and so the only way is to make you rebuild a new password. Okay, so let's go back to the ATM cards. Also your bank, I'm sorry to inform you, well, if it is a serious bank, does not store your personal identification number. It simply creates it, gives it to you, and then destroys the information. Doesn't store, because it's dangerous to store the PIN of the customers, because if anybody hacks the bank main system and finds one of the customer cards, can withdraw money without any problem, because looks at the PIN in the bank system. So it's pretty dangerous. What does the bank do exactly? Well, the bank, your ATM card has a number. So card number, let's make an example. 1137862. Okay. Your bank creates the PIN, an easy PIN. Okay. So your bank creates the PIN. So the PIN is usually randomly created by your bank. Okay. At this point, your bank does the following: create a string made up of the card number concatenated with a PIN. This is clearly a simplified algorithm. I hope that your bank uses better algorithm. Okay, so let's go. Not string is not a good name. String to hash. Okay. And then your bank calculates the SHA-256 of the string. So from hash lib import SHA-256. hash, hex digest. Okay, this one is the SHA. At this point, the bank does the following. Gives to you the card. The card number is known by you and by the bank. Oops. Known by you. This one created by the bank, then forgotten and known only by you. This thing here instead is known only by the bank. So the bank at the end knows your card number and your SHA. Okay, doesn't know your PIN. Only you knows the PIN. Okay. Whenever you go to an ATM, so this is your SHA. Okay, whenever you go to an ATM to withdraw money, you slide the card inside, and on the card is written this number, not your PIN. Many people believe that the PIN is secretly written inside the card. No, otherwise anybody who takes your card and has a card reader. Okay, so you slide the card inside so the ATM can read your card number. Okay, you have to digit the PIN with your fingers. Okay, the ATM machine. So, PIN attempt. Suppose you digit your PIN, a wrong PIN, so 1, 2, 3, 4, 5, 6, you add a number. Okay. The PIN machine, the ATM machine, calculates the string to hash. Attempt as your card number concatenated with the PIN that you have digited. Okay. Then calculates the SHA. Oops, sorry, string attempt. And then sends this SHA code to the bank and asks the bank, is card 1137862 associated with this SHA code? The bank checks and says no. The bank doesn't say your SHA code. The bank says no, it's not associated with that SHA code. And so the ATM says wrong PIN. Okay. Or it could be wrong card, because it can be both. So this is a trick commonly used by this system, but also by website exactly the same way, to avoid having to store your PIN. So only you is the only one who knows your PIN, and to check whether your PIN is correct, they concatenate it with your card number, calculate the hash, the SHA-256 in this case, and check whether the hash is correct with the hash inside the bank system. Okay, it's impossible, given this number here and your card number, it's impossible to deduce what the PIN is. So it's impossible, given the SHA and the card number, to deduce what the PIN is. Because the rule to calculate the SHA-256 is terribly complicated, and it's a function which cannot be inverted. So you cannot, from the SHA value, deduce how was it generated, so which thing generated it. But you can do something different. If you have the card number and the SHA value, you can try all the possible numbers, starting from 1, 2, 3, 4, 10, 11, 12, 100, 101, 1000, 1001, 1002, 1003. Can try all the possible numbers until you manage to catch the right SHA. Okay? And now you understand why after 3 failed attempts, the ATM cancels completely your card. So your card is not valid anymore, or takes your card. So your card, I think after 3 failed, or after some failed attempts, it cannot be used anymore at all, to avoid that somebody continuously tries all the PIN until it finds one which matches your SHA. And this is also the reason why this SHA number is kept on the bank server and is not written on your card inside. Okay, so if you plan to have a future as a hacker, you will start your future as a hacker in the exercises which are associated with this lesson here. But I'm sorry, the SHA usually it's kept secret on the bank system, and after somebody tries to check the validity of that SHA for 3 times and failed, that SHA is deleted and the card cannot be used anymore at all. So you have to change card. Okay. So exactly the same thing is done with passwords. With website password, well, if your website is not serious, simply stores the password, we say in clear, so written as you have written it, so they know it. If your website is more serious, whenever you register, you digit your login name, you choose a password, it does not store the password, simply takes your login name, concatenates it with your password, calculates the SHA, and stores the SHA. Okay, so the website doesn't store your password, simply stores your SHA number. Whenever you try to log in, you have to submit the login name and password. The website calculates the SHA. If the SHA corresponds, fine, you may enter. If the SHA doesn't correspond, you may not enter. And after some attempts, the website locks completely that login name to avoid that you try all the possible combinations until you find the right one. Don't worry, also this one will be an exercise for this lesson. You will have to build a password cracker, so a program which tries all the possible combinations until you crack the password. I managed to crack a password of 4 letters in some seconds. Okay, there is a third usage of the hash functions, the SHA-256 in particular, because it's the most widely used. This part, as you can see, doesn't have any exercise, so it's theoretical and it can be asked in the cryptocurrency and blockchain technology part. Using the SHA, the hash function, to prove the existence of something. Imagine you have a book and you want to publish it in the old way on paper. So you send your book to the editors. Your editors, if they are kind, reject your book. If they're not kind, they don't even consider your offer, unless you are very famous. And at this point, what could happen? It could happen that one of the editor finds your book and say, very well, I will publish this book, but with my name as an author. And you have no way to prove that you have written the book before. Okay, this can apply to several other things, obviously, inventions or whatever, your arts, whatever. There are some ways to protect yourself, to protect your rights. For example, for invention, you have the right to claim for a patent, okay, and other ways. In some countries, you can go to a public office and deposit your book, and with it will put a stamp with a date. But usually these ways are pretty expensive and not so easy to make, not convenient. Okay, especially for some things which are not inventions. You can do something different, something more technological, something more 21st century like. You can take your book. Your book, after all, is a sequence of words, okay, and hash it. So calculate its hash. It will be just a little string. You can do the same for pictures, because a picture, after all, is a file. Okay, the file, you can convert the file to a long string of text, and you can hash it. You can do the same for any document, PDF. You can do the same for a database, for a video, because everything on a computer basically is a file, and the file can be always converted to a string in an easy way. Just it contains strange characters, but it can be everything can be converted to a string. Okay, and you can hash it. So you can hash basically everything on a computer system. Once you have hashed it, you can put it on a place in which it's sure that it existed at that time. How? Well, if you live in the 19th century or in the 20th century, you can, for example, write it on a newspaper. You can pay an announcement to publish your little hash string, so you can say, I've written this book, and put a hash. So you don't put a book, so you don't publish the book, but you put a hash. Okay? And it's written on a newspaper on a certain day, and it means that on that day you had that book. if you have later on to claim that the book was really that one, well, you can take the book and prove that if you hash your book, you get exactly that string. Since it's impossible to reverse this operation, so it's impossible for the string to reconstruct the book, you are safe that nobody copies your book, and you have anyway a proof that your book was written before, because you are able to calculate the hash at the time in which the newspaper was published. Well, if you want something more 21st century like, you can calculate the hash of your object, book, picture, whatever, and put it on a cryptocurrency blockchain. Many cryptocurrency blockchain accept that you make a transaction, and in the transaction there is a little description field, which usually is large enough to put a hash fingerprint inside. It's designed exactly for this. Usually the space of the description is exactly large to put a hash description. Okay, you cannot load an entire book on a cryptocurrency blockchain because it's too expensive. I calculated last year that to load 1 megabyte, so not gigabyte, megabyte, on the Ethereum blockchain, it will cost $4,000. So you cannot load a book on the Ethereum blockchain, as many people believe you can. No, it's not that one. If you want to load something, usually you load the hash of the book, and in this way you have proven that that book existed at that time, because the cryptocurrency blockchain usually has a precise timestamp for each block. Your transaction will go on a certain block, there will be your hash on that block, and you are able to prove. If you believe that this idea is bizarre and futuristic, I tell you that I went to a conference more than 1 year ago, probably 2 years ago, and I found a company in Sardinia, a water supplier company, a water company, which took the picture of the water meters, put all the pictures, each picture was hashed, so the hash fingerprint of each picture, put all the hash fingerprints on a document, hash all the hashes, and so finally they get a single hash for each day. Each day they get a single hash, which was a hash of the hashes, and each hash was the hash of a picture. Okay, and they put that hash on the Bitcoin blockchain for a fee which is something between, let's say, €0.50, maximum 5-10 euros. So for less than 10 euros, they have every day the proof that the picture were taken before that date. Because they had customers which complain and claim, oh no, you took this picture yesterday instead of 1 year ago. And they say, no, we took the picture 1 year ago because the hash of the hashes is on the Bitcoin blockchain and we can prove it. So clearly this requires technicians to be able to explain the thing to a judge. But in this way you are able to easily and automatically prove that something exists at a certain point. Okay, just with a short money expense. Fourth usage, mining bitcoins. Yeah, the hash is used for Bitcoin mining. Probably, if you have attended my lesson on cryptocurrencies, and if you didn't, too bad for you, you remember what I say, that I say Satoshi Nakamoto found a solution to decide who has the right to confirm the transaction. So we must find out who has the right to confirm the transaction. It cannot be a central authority because we don't want to use central authority. Everything is decentralized. So, and who has the right to confirm the transaction? And I say the first one who solves a difficult mathematical puzzle that can be solved only by trial and error. I couldn't explain it any better because at that time you didn't have any idea what was a hash function. Well, now it's time to tell you what is this sort of puzzle. Okay. I will just make a quick idea. I will skip and deliberately change some technicalities to avoid bothering you with binary numbers. Okay, the puzzle is the following. Pay attention. You decide which transaction must be confirmed, which Bitcoin transaction must be confirmed. Okay. Concatenate, not concatenate. Okay. You have all the list of the transaction. Fine. Then you concatenate them with a hash fingerprint of the previous block. So you know the Bitcoin blockchain, there is a block after each other. So you calculate a hash fingerprint of the previous block. We will see that you don't need to calculate it yourself, somebody has calculated it before. So you take the hash fingerprint of the previous block. Why? Well, because in this way you can start solving the puzzle only when the previous block exists. So you cannot try to solve the puzzle in advance to have a time advantage over the other. So only when the previous block exists you can try solving the puzzle. So you take the hash of the previous block, concatenate it with all the transactions that you want to confirm, okay, and then look at this one. This is strange. Wait, the Mac does not working. Okay, concatenate it with whatever you want, technically called nonce. You can put whatever you want after. Then you calculate the hash. If the hash of these things starts with 8 zeros, congratulations, you have solved the puzzle. If it doesn't, try. Why today the Mac doesn't? Try to change this one until you find the right one. And this is the puzzle. So you have to try and retry to change this whatever you want until you find a hash fingerprint which starts with 8 zeros. Okay, you can try. Oh, Satoshi in his first block, well, managed to find it with 10 zeros, so exaggerated. Okay, I do, let's see a little example. Okay, when I was writing this file, the last block which was mined was block 605377. Okay, let's see now which is the last block which was mined. Blockchain.info. Oh, this one. Okay, this is the last block which is mined. Okay, this is the hash. Oh, let's see. This is the block. Okay, let's try to reproduce this block. I hate the Mac. There is no way. Can't use it. Okay. Oh, my face has disappeared. Okay, you will make it without it. Okay. Okay, so this is the block, last block which was mined. Let's take some transactions from it. I just copy and paste. Ctrl C. Ctrl V. And let's build a list of transactions. So current block equal. Where is the square bracket? Alt 5. Okay. So it's a list of lists. Okay, I'm not interested in the hash. Okay, so we start. Coinbase, it means that they were newly generated. This gives 12.5 bitcoins. To whom? To this address here, which is the address of the miner. Okay, which gets this amount of Bitcoin. And this is the first transaction. So you can say, how it's possible that the first transaction, 12.5 Bitcoins, start from Coinbase? It means that they are generated, this is the reward. Do you remember when the cryptocurrency lesson in which I said every person who managed to solve the puzzle receives a prize of 50 Bitcoins. Now the price is only 12.5. Okay, so 12.5 Bitcoin. And you can ask me, why 12.5 Bitcoin come out from Coinbase and when they arrive there are more? Because they include the fees. All the fees of the block go here. Comma. Second operation. Okay. From this address, comma, we have this amount of Bitcoin, comma, Okay, I skip one, but it doesn't matter. I hate not having a mouse and a proper keyboard. And with proper, I mean which uses letters as they should be. Okay. Comma. Okay. 6, comma. Okay. So from this address, 8.23 bitcoins come out. They go partially to this address and partially to this one. All the rest is not necessary. Then, if I remember, this transaction has several input, several starting addresses. We call them output addresses, so I skip it. Just for simplicity. We don't deal with transactions which have several. Okay, can you see? The third one. This is the first one. The third one is a transaction which has several. It's the same, by the way. Several starting addresses. We call them output addresses. We skip them, so just for the sake of simplicity. Let's consider this one instead. So, Alt 5 from this address. 13 Bitcoin, wow. Go to this address. Okay, finish. We close here and we close the entire list. So we have a list of 3 transactions. The first one is simply generating the reward and getting the fees. The second one is a transaction from this address to these 2 addresses. The third one from this address to these 2 addresses. Okay, fine. The format I want is always output amount, input amount, input amount, input amount, input amount. Okay, so previous block hash. The hash of the previous block. So we have to go to the previous block. So our block is 0.5448. I go back. Okay, this is the previous block. Let's copy the hash. Okay, copied. Can you see that now the number of zeros that you have to find has increased? This is called the mining difficulty. This number of zeros, currently it's very hard. The mining difficulty has increased. At the beginning it was 8, now it's something like 17. So the mining, the more computer work on the network, the more zeros you have to find. So probably the next one will be 18 here. Okay, so now we concatenate. Let's call it block. Let's call it P. Just I don't know what to call it. So we can. It's the previous block hash concatenated with the string version of current block. Okay. It's not exactly like this. You don't calculate the string version of a Python list in Bitcoin. You calculate something smarter. Okay. Now we hash it. Where is the hash? Here it is. No, sorry. We have to add some random numbers. You can add also characters here, but we will see, or better, you will see during the exercise at home that it's much easier to add numbers. So I add a random number. Then I try to hash P and see whether I'm lucky and I get immediately a hash which starts with 8 zeros. No, my hash doesn't even start with 1 0. Okay, so what mining computers do? Mining computers try these numbers Usually they start from 1, 1, 2, 3, 4, 5, 6, or if you want to be smart, you just try random numbers, or you start from 1 billion and go backwards and then go forward, whatever. They have their own techniques, but everything is pretty random. And until you find a hash which starts with 8 digits. Okay? Well, according to what Satoshi has written, and according to what I have tested tonight, it takes to a standard computers some hours to get the result. Okay? So, if you are doing the exercises, first of all, don't try to find a hash with 19 zeros, because forget about it. Even to find a hash with 8 zeros, it takes some hours. So just try to find a hash with 6 zeros, for example. So it starts with 6 zeros. So you can try to change this number. Let's see. 4. No. It's very easy to find a hash which starts with 1 0. It just requires 8 attempts on average. Let's see. Just to start with 1 0. It requires 8 on average 8 attempts. Let's see whether. Oh. It requires on average 8 attempts, but you know, the difference between average and real life is... Will it ever arrive? Why haven't I written a program to do it? Oh. Oh, finally found. Okay, so after 20 attempts I found with 1 0. Okay, you can imagine how much does it take. Okay, lesson is over. Goodbye.